Okay, so in the second video here, I'm going to go over how do you get all your values for the slot 0 configs, and as well as a few other things in TunerX that you'll have to do. You should already be familiar with kind of what each variable is, and what you'll need set up now will be TunerX, your robot. Make sure you're connected to your robot and are able to deploy code and run the robot. So make sure nothing's in the way. You're not going to hit anything when you move your mechanism, whether that's an intake, an elevator, something else. So in TunerX, select the motor that you're going to apply all the motion magic stuff to. And the first thing I want you to look at is the plot tab up here. We're going to start off by assigning our KV and KA values. So you'll need to plot acceleration in rotations per second squared here and velocity. Just the regular velocity, none of the fancy stuff, rotations per second. With that set, you can see we can play it and we can graph all of the values here. Okay, so pause and clear. Over here in the config, we'll use these values later. I just want you to see where the tab is. And then down here, this is where you're going to actually run the robot. So you can see we're disabled here as well as we were disabled in driver station. So right now the robot can't move or do anything, and make sure the voltage out setting is applied. What I would recommend is you've got 3 little presets down here. I would set up -1 and -2, or whatever direction is like out or forward for you. Obviously, like it might be different if the motor is mirrored, but for us, we have negative direction is forward. Okay, so what you're going to do now is you're going to make sure you know what voltage you're running it at, and we're going to simply run the motor at that voltage and record the acceleration and velocity, and then we're going to do a bit of math to graph the actual value we need. So, driver station, I'm going to enable, and I'm going to start this, and apply this, and enable. Okay, and then I disabled. Okay, I'll pause the plot here, and you see we've got a bunch of values to work with. So this initial drop in acceleration, which is the blue line, down here, that's the value we want. So negative 0.75. And I can take that value. That value will be the voltage, which is -1, divided by that value, 0.75. Gets us a value of 1.33. So back in the code, we're going to throw the 1.33 in as our KA. All right, back in here, this is about where the velocity kind of settled around here. So we have negative 0.219, and -1 is going to be divided by that. So 1 divided by 0.219. We get a value of 4.57, rounded. 4.57. Okay, so let me add those to the other computer. So 1.33. So with those being added in, we can move on to the next value. Sorry, we're going to do something to check those real quick. So back in TunerX, you see I've got the -2 as well. If we clear the plot, reset the position of the mechanism, and then we should still be enabled. Yep. Okay, so I'm going to apply this, play, and run. Make sure you're paying attention to it because it'll move a bit faster. All right, we're going to pause, and you see we've got some larger values. However, we're doing -2 divided by those values this time. So 2/3, the voltage divided by the acceleration, and we get a value of 0.667. So we're going to lean more towards this set of values because you're probably going to be running your mechanism faster than what it would be at just the 1 volts. So I'm going to lean more toward this value. So I'm going to give it a value of 0.8 as opposed to the 1.33. Okay, and I'm going to enter that into here. So this value was for 1 volt, and I'm going to lean closer to the value we got at 2 volts. All right, so we'll do the same thing with the KV. We'll find where the velocity settled, which is around here. That's 0.406, so I'm going to go 2 divided by 0.406. It gives a value of 4.93, which is quite closer. So I'm going to give this a value of 4.80. Okay, so that's a pretty good estimate for what our values will be. I would recommend, if you really want this to be more accurate, do more tests, maybe voltage a bit higher, maybe try like 1.5, 2.5, 3, get all the values and then average them out, maybe leaning slightly more towards the higher voltages, as you're probably going to be running your mechanism at a bit faster. I mean, maybe if it's slower, then it isn't too big of a deal, but the more tests you run, the more accurate your value is going to be. This is just a quick demonstration of how you would get a value. Okay, so next we're going to move on to the Ks and Kg values. This is the voltage needed to overcome static friction and gravity, respectively. So with the Ks, we need Ks to calculate Kg, so we'll start with Ks. So I'm going to clear the plot. We do not need acceleration and velocity anymore, so I'm going to clear those out, uncheck them out of the Signals tab. And we don't actually need anything in the plot tab right now. However, you can't see my mechanism, but you're going to put it directly vertical. Put it in a way where gravity isn't a factor in this. So for me, it would be straight vertical, so then any direction, all it's doing is overcoming the friction in the gearbox rather than anything to do with gravity. And I'm going to set a value of 0.1 here. Apply. And we still should be enabled. Yep. Okay, and then I can just run, and I'm not getting any movement. That makes sense because it's a really low voltage. So that is not enough to overcome the static friction. So let's do 1, 3. I'm hearing a bit of movement, but I'm not seeing it. So let's go 1, 4, apply. And that did just barely move from the vertical position. So I'm actually going to set that value as a positive in our code. We don't need the negative. 0.14. So let me quickly add that to the other one. Okay. Finally, we're going to figure out, to find the kg, it's the total voltage to overcome gravity minus static friction voltage, because obviously that's already being factored in the Ks value. So to find the kg value, what I'm going to do is I'm going to put my intake mechanism perfectly horizontal. And you'll need to support it because it should fall. That's the whole reason we're finding the value, is because gravity is a factor in this. And so while it's perfectly horizontal, I'm going to change direction to positive, so it goes the other way for me. Again, for you, direction will vary. I'm going to start off at 0.2 this time. And apply that, and I'm going to see if that's enough to make it move. So it's still sitting, so I'm going to go no. So I'm going to go 2, 1, apply. Still not enough. It's trying, though. It actually is supporting itself. Again, not enough. Let's go 2, 5. Still not enough. Up to 2, 7. Still not enough. Let's go 2, 9. Yeah, not quite. I'm going to jump up to 3, 5. Make this a bit quicker. Okay, that did work. So I'm going to go down to 3, 4 and see if 3, 4 is enough. And it's just barely moving. So I'm going to call 3, 4 as our total voltage needed to overcome gravity. Now that is gravity and the static friction in the gearbox. So we're going to take 0.34 and subtract it from 0.14. Sorry, subtract 0.14 from it, and we'll end up with a value of 0.2. Okay, so that's our kg value. Okay, total voltage minus the Ks that we've already determined. So with all that being done, the next thing I want to include would be the home position. This might not be useful for everyone, but essentially what you're going to do is you're going to plot the position in its neutral state. So for our intake mechanism, when it is sitting in its disabled robots off position, it's actually not in the exact position we want for it to be loaded. And so it needs to move up just slightly. So you would just go into your plot, you're going to plot your position, and whatever the desired position of like your resting state you want when the robot's on, like for like loading to shoot or whatever, that value that you get when you plot it will be the value that you want to record. So that's about the value that we have in our home position, which is where we want it. I think this Approximately this is what we have. Yeah. So again, whatever you need. It doesn't. Not everyone needs this value. It's just used as like an offset. If you require it. Okay, but we will still need position to be graphed because now we're moving on to the KP value. Okay, so you need to follow the steps of instructions very closely. The first thing you need to do is actually deploy your code. I have it open on another laptop right now, so I'm going to deploy onto there. Make sure it's connected and all that. Okay, I'm going to quickly disable. Okay, deploy. Okay, the next step you'll need to do is right now we have to get out of this because it's all going to shut down. But you're going to need to set up the motion magic acceleration and velocity. You'll do that in the configs spot, which was off to the left, like I mentioned before. One sec, just starting back up now. Okay, so the idea with the p-value is that if you want your mechanism to move to a specific place, we'll need to tweak how aggressive it is in forcing the mechanism to stop and controlling its movement. But we needed to have all those other values we've already determined, kb, ks, kg, ka, all on the robot before we can do that. So going back into Nick rotation, if I go under configs, I should see all our values on there. And as you can see, they're all listed here. It looks like it's put in some decimals, but that's close enough for what we need. Okay. So down here first, you'll need to go to the motion magic tab, and you'll see motion magic acceleration and motion magic cruise velocity. We're going to set those equal to 1 to start. Now keep in mind, 1 does make it go a little fast, so you'll need to really watch when you're running your motors. Closed it. Okay, you see we got 1 and 1 here. So now what I'm going to do is I'm going to select apply and flash configs right up next to the TalonFXConfig set of words. Right, you should hear robot beep. And you'll see down here the configs read from the dice do not match the configs that were written. That's fine. That just means that we're manually changing stuff in the motor when it's not changed in the code. Because the only reason we're doing this is for the sake of finding our values. So down here, it was listed under voltage out before. We're going to switch that to motion magic voltage. And what this allows us to do is actually graph the position, or sorry, apply a set position for it to move. So we'll need to plot the position again like we had up earlier, right there. Okay, and what I need you to do now is click play and move your mechanism to the state you want it in. So like for our intake, it's over the bumper, so I'm going to put it to where we would want it if we were like intaking a note. Okay, and that value is going to be negative 0.104. 0.104, and I'm going to put that in one of the preset slots. So now I can quickly ask it to move to that position. Now up here, this is where our value is actually going to be. The KP value, I'm going to start at 0.1. Very small value. It'll help us, start small, see, and work our way up. Okay. So after that, you're going to want to actually run the robot. So I'm going to pause this. I'm going to go back in driver station, enable here, clear the plot, and play, apply, and I'm going to enable. Move to the position, and I'm getting negative 0.114. That's not quite close enough for me to be happy. It's pretty much, usually what happens is gravity plays more of a role. So you want the p-value to get to a point where it's stopping gravity from just forcing it all the way down. So I'm going to increase by factors of 10 until it gets pretty big, and then I'll just start adding like 100 or so. So I'll move up to 1 as a value, clear the plot, reset the position of the mechanism, play, and enable. Okay, as you can see, we're getting closer. Shifting there a little bit. That's fine. I want it a bit higher, though. I'm going to, again, multiply by 10. Clear the plot. Position is reset. Enable. All right, could be a bit more aggressive. So I'm going to move that up to 30. Again, you don't want to jump too quickly. Obviously, if you keep multiplying by 10, it'll just get a bit drastic. So let's try that. Oh, sorry, I'm reading the wrong value. Let me go back to 10 and we'll double check and see how close that is, because that last one was pretty close. I had another number in my head. Okay, so we'll enable. That could be a bit closer. Let's jump back up to 30. Okay, clear the plot, apply again. Remember, we're trying to get to the value that we have listed down here. That is quite close. So I'm going to say that 30 is a fine value. Tweak this as you need. Keep doing more tests. Maybe, you'll jump up and you'll go, maybe it's too accurate when we don't need that accurate. And then there's the IND values as well. You can experiment with that at your own will. I would recommend looking at another video on how they work, because for the most part, most mechanisms only need the p-value tweaked. And after that, anything else is more of a luxury, or if you have a very specific mechanism that needs those values to help it better. Okay, so with that being said, you'll enter that value into your P or your KP slot in the code, which we had at 30. And then after that, I would re-upload the code and all of your values will be applied. And so that is everything you need. Those are all the values that you'll require. Again, I and D are very much optional, and everything else is filled in here. Okay, you do not need to enter the magic motion stuff. That was just for the purposes of testing, so that we could use the setting in TunerX. Okay, so hopefully this has helped, and if you're coming from the textbook, continue reading to figure out how everything else works out. Thank you.